Worksheet number 3, question 6. We've got our 3 rings for our Venn diagram. We're told that the group has 35 people in it in total. So that means we've got an omega of 35. So our sample space has 35 people in total. We start off, we'll label these as left-handed, glasses, and brown hair. Next thing I want to do is put in each of the number of people that are in each of those categories, keeping these outside of the Venn diagram. 7 people are left-handed, 15 people wear glasses, and 17 people have brown hair. Now let's go ahead and look at the AND statements that are in the problem. We're told that 3 people with brown hair wear glasses and are left-handed. So that's the intersection between all 3 areas. So left-handed, glasses, and brown hair. We put 3 at the intersection point. Then we've got 7 people have brown hair and wear glasses. So that intersection is the intersection between brown hair and glasses. If there are 7 people in total there, and we've already got 3 in place, we can say then that there are 4 in that spot. We're also told that 5 people wear glasses and are left-handed. So again, with an AND, that's the intersection between left-handed and glasses. Since we've already got 3 there, and we're told there's 5 in total, we can subtract the 3 from the 5 and figure out that there are 2 in that space. Now we look at the OR statements. We're told that 25 people have brown hair or wear glasses. If we put that into set notation, we've got brown hair or glasses. There are 25 people who meet that category. Similarly, we're told that there are 20 people who are left-handed or have brown hair. So left-handed or have brown hair. There are 20 people. Now we can go ahead and fill in the rest of the table. Our total number of glasses people have to come up to 15. Right now we've got 2 and 3 is 5 plus 4 is 9. So we'll need to add an additional 6 people into that space. Now it gets a little bit trickier from this point on. We need to look at our total area, our glasses, and our brown-haired people. And we know we need to end up with 25 in total there. Right now, we've got 15 in the glasses space, so that means there have to be 10 in the brown hair category. What we don't know is whether they'll be on this side or that side of this line. Chances are there's going to be some in both areas. So for now, I'm just going to put that an additional 10 people that we need to get to 25. I'll just put it on the line for now. Now let's go ahead and look at where the left hand is in union with the brown hair. So we've got left-handed or brown hair or left-handed union hair. So that's describing this area inside these 2 spaces. So it's everybody that's in there has to total up to 20. Right now in brown hair, if we look at who's in the brown hair space, we've got a total of 17 people there. If there are 17 people there, so it tells us that we're missing 3. We know we need to have those 3 in the area that's left-handed, but not brown hair, because brown hair has already got their 17, so that remaining 3 has to go in that area that's outside of brown hair. Since we've already got that 2 in that space, adding 3, saying that we need to have 3 in total there, means that what we really end up having is just 1 more in this space. So the 1 and the 2 will give us the 3. Let's just do a quick check now to make sure this is all adding up the way we want it to. So in the left-handed and brown hair space, we've got 4, 3, and 10, which gives us 17, plus 2 is 19, and 1 is 20. The last issue we need to address then is the question of this 10. Which side of the line do they need to be split across, or how do we need to split up that 10 to fit across into each of those spaces? We can do that by looking at the 7. In the left hand, we've got 1, 2, 3. Those are definitely in the left-handed space, so that's 5 plus 1 is 6. So we're missing just 1 in the remaining space. If there's 1 there, then we know based on this 10, we're going to take 1 away from that, which leaves us with 9 in this space. And with that, we've now completed the Venn diagram. Now we need to confirm that we've got the total number, that we're meeting our requirement to have 35 in the sample space. So we've got 9 and 1 is 10, plus 6 and 4 is 20, plus 2 and 3 is 25, and 1 makes 26. Since we need to end up with 35, that means we have 9 more that are outside of each of those categories. So they are neither left-handed, nor do they wear glasses, nor do they have brown hair. At that point now, we have completed our Venn diagram. So this is a more algebraic approach to solving the problem. We start off in exactly the same way, so that you end up with 2, 3, 4, and 6 in the glasses area. So we've got that covered. That was very clear from the information that we were given in the problem and from doing some simple math. Now what we're left with at this point, though, are 3 spaces. We can label them as x, y, and z. From that, we can actually develop some equations that are based on the information that we have here in those 2 spaces. Remember that we said left hand union with brown hair was equal to 20 people. So, and again, to recap, that's defining this space that's encompassed by the left hand and brown haired people. So we're going to use that information when we get into the algebra. So the first thing we do is we can look at just the left hand, and we can see that if we take x plus y plus 2 plus 3 will be equal to 7. So x plus y plus 2 plus 3 is going to be equal to 7. We can then simplify that a little bit down to x plus y is equal to 2. Right? We subtracted the 2 and the 3 from both sides, so the 7 was reduced down to 2. That gives us our first equation. Now I'm going to look at the brown-haired people, where we've got y plus z plus 3 plus 4, and that's equal to 17. We can also simplify that down. Y plus z is equal to 10. So we've subtracted the 3 and 4 from both sides, and we get 10. That gives us our second equation. Our final equation is bringing everything into play. X plus y plus z plus 4 plus 3 plus 2 is going to be equal to 20. And we simplify that. We get x plus y plus z is equal to 11. That's our third equation. Now I've got 3 equations and 3 unknowns. The first thing I want to do is take my x plus y equals 2, and I can sub that into equation number 3, where I have 3 variables. The x plus y will get replaced by the number 2. So 2 plus z is equal to 11, therefore z is equal to 9. Once I've got z, I can substitute it into y plus z equals 10. So I've got y plus 9 is equal to 10. Subtracting 9 from both sides, I get y is equal to 1. And finally, now that I've got y equal to 1, I can substitute that into my first equation of x plus y equals 2, which means x plus 1 is equal to 2, so x is also equal to 1. So I can replace the x, y, and z with 1, 1, and 9, just as we did in the previous example.